Worldwide, glass manufacturing produces at least 86 million tons of carbon dioxide every year. A new type of glass promises to cut this carbon footprint in half. The invention, called LionGlass and engineered by researchers at Penn State, requires significantly less energy to produce and is much more damage resistant than standard soda lime silicate glass. The research team recently filed a patent application as a first step toward bringing the product to market. LionGlass eliminates the use of carbon-containing batch materials and significantly lowers the melting temperatures of glass. Soda lime silicate glass, the common glass used in everyday items from windows to glass tableware, is made by melting three primary materials: quartz sand, soda ash, and limestone. Soda ash is sodium carbonate and limestone is calcium carbonate, both of which release carbon dioxide CO2, a heat-trapping greenhouse gas, as they are melted. During the glass melting process, the carbonates decompose into oxides and produce carbon dioxide, which gets released into the atmosphere. But the bulk of the CO2 emissions come from the energy required to heat furnaces to the high temperatures needed for melting glass. With the LionGlass, the melting temperatures are lowered by about 300 to 400 degrees Celsius, which leads to a roughly 30% reduction in energy consumption compared to conventional soda lime glass. Not only is LionGlass easier on the environment, it is also much stronger than conventional glass. The researchers said they were surprised to find that the new glass, named after Penn State's Nittany Lion mascot, possesses significantly higher crack resistance compared to conventional glass. Some of the team's glass compositions had such a strong crack resistance that the glass would not crack even under a 1 kilogram force load from a weakest diamond indenter. LionGlass is at least 10 times as crack resistant compared to standard soda lime glass, which forms cracks under a load of about 0.1 kilograms force. The researchers explained that the limits of LionGlass have not yet been found because they reached the maximum load allowed by the indentation equipment. The researcher explained that crack resistance is one of the most important qualities to test for in glass because it is how the material eventually fails. Over time, glass develops micro cracks along the surface which become weak points. When a piece of glass breaks, it is due to the weaknesses caused by existing micro cracks. Glass that is resistant to forming micro cracks in the first place is especially valuable. Damage resistance is a particularly important property for glass. The researcher says that think about all the ways we rely on the strength of glass in the automotive industry and electronics industry, architecture and communication technology like fiber optic cables. Even in healthcare, vaccines are stored in strong chemically resistant glass packaging. The improved strength of LionGlass means the products created from it can be lighter weight. Since LionGlass is 10 times more damage resistant than current glass, it could be significantly thinner. The research team is still evaluating the potential of LionGlass. They have filed a patent application for the entire family of glass, which means there are many compositions within the LionGlass family, each with its own distinct properties and potential applications. They are now in the process of exposing various compositions of LionGlass to an array of chemical environments to study how it reacts. The results will help the team develop a better understanding of how LionGlass can be used throughout the world.